And then here we're going to graph the function and its inverse. So one thing that we want to do is we're going to take the original points of the graph. So here's the graph given to you. And I just picked 3 points, the endpoints of each piece. And I labeled them. So 2, -3, 5, 0, 6, 8. The great thing about graphing inverse functions is that you are just going to graph the opposites. So for example, we're going to flip x and y. So if this was x comma y of my original function, all I'm going to do is graph that flipped. So instead of 2, -3, its inverse coordinate point is going to be -3, 2. So I'm actually going to graph -3, 2. So here is its inverse point. So notice that our x and y are going to be flipped from the original function to its inverse. In the same way, I have 5, 0. If I flip x and y, I'm really going to be graphing 0, 5 for the inverse. So 0, 5 for that inverse. I'm going to write that. So 0, 5. In my original function, if I have 6, 8, then I'm going to graph by flipping it 8, 6. So I'm going to go to the right 8 and up 6, and this will be the point 8, 6 of my inverse. So now I just want to connect the dots just like I had here. So connect each point with a straight line. So there's this one and, whoops, that one. So if we see, remember inverses are symmetrical about this line, y equals x. And so if we were to draw that perfectly, we would see that the right side of this graph flips onto the left side of this graph. So given a graph of your original function, if you want to find its inverse, all you have to do is flip the x and y coordinates to find the coordinates of the inverse function.